4 weeks.
Oh, I know.
Well, again, when you leave it in here, you're taking that chance. So try to look around and find it. It might be under the seat. Leave your book in here and it gets moved around. I doubt anybody takes it, but they might move it around. Not much I can do about that. You need to grab one of each of these packets, so you will walk away with 3 things. Not all packets, really, but. And I'll tell you what they are. I'll tell you what they are in a minute. You got it. Thank you. You guys got to start getting here early because that's 2 days in a row, I believe, where you're not here by the time bell rings. And try to look down the hall, but from now on, I need to pass if I haven't looked down the hall. If you're still out in the hall. All right. So Marlon, you got me on that? You need to be in this classroom when the bell rings.
Sure, that's my first time.
Nobody's asked, so, well, it may not be right at the 10 minutes, but yeah, as soon as through the break, yes. That's the.
Yeah. They're really good. Oh, yes.
Yeah, no, I want you to have them so you, like, you know, if you're getting it right or not. That's just for you to practice, like, just practice for the retake. Not to say anything. And yeah, again, you gotta, but at least you can know whether you're getting the right answer or not. You should know how to do those. Those aren't super difficult. But you need to go back. I did a video on those kind of problems. I did a video on my YouTube that says practice problems, page 67. So it's those same kind of problems. It might even be the same exact problem. All right, so do that. I'll give you like 1 minute. And we get out at 45, so you have 44 minutes. Why did that go so speedy? Mm-hmm. What do you think? There's 1 grade and that is it. What's that? I mean, exit tickets count as that, but. Yeah. These are to help you prepare for those retakes. Those of you that keep thinking you're getting saved by something like that, that's not going to happen. I've had that talk a million. I'm already getting emails. What can I do to get my grade up? What can I do to get my grade up? Not much now. Well, yeah, 4 quizzes, I guess. Yeah, that's due Wednesday, the 2nd. I'm going to talk about that. That's the only way we're going to talk about it. Well, you need to check, because if you need tutoring, you have to do those easy IXL. Do it quickly. Only don't allow that, but since I'm kind of letting you do your own things. What was that? Can you send it to me? Are you sending it to me?
No.
Oh,
Everybody has the 3 packets, right? One of them is only 1 page of the packet.
started. Why did we never get directly hit? This thing. It's by hurricanes.
Well, if you research it, there's all kind of things that they say. The thing that I have read is it has something to do with the jet stream of the water, not jet stream, but the water currents is one of, because it's very warm water. And then there's also something about the way the wind currents normally work, or the wind, like, there is, now again, they may just be justifying the fact that we haven't gotten hit. It may not be true, but. Was that? That's what you think?
That's what I was.
Yeah. Oh, okay, you stick with it.
No.
All of Florida has native Indian tribes, so a lot of Florida gets in.
It was
Like literally, it's the Florida State Seminoles in North Florida.
It was just
Like
a-
their schools.
I know it's county.
Hey,
Yeah.
leave whatever you want to leave, man.
That's what you used to.
I mean, if you found it on Google, it's gotta be true.
That was
There's everything on
the
Google.
dumbest theory. Like, that was so freaking retarded. Go ahead. You just aggravated me. Shut up. I didn't even say you just aggravated me. She literally.
All right, so I'm gonna go ahead and do this because we gotta get, oh, I already waited too long. So this kind of math is killing you guys. This kind of math is killing you guys. A lot of you, some of you are getting it. If you cannot do this, and this is not super complex algebra. I mean, you should all be, now, maybe you forgot it since last year, but you've had plenty of time to relearn this kind of algebra. If you are limiting yourself to a top end of a C, because you can't do algebra, then you gotta be perfect on everything to get the C. Learn the algebra. It's not super complex algebra. What would you say? You should know this by talking to you. What would you say is the number one rule that you have to follow when you're solving equations? So that's the goal, is to get the variable by itself. That's more of a goal. But when we're going through the process, what's the number one thing we have to do, to remember to do as we do steps? What'd you say? And it's absolutely what I would say. Again, there's no official number one rule. Whatever you do on one side, you have got to do it on the other side. Oh, I am recording. So yeah. So here's why I make that the number one rule. Because it fixes a lot of the mistakes that you guys make all the time. If you follow that one rule, it'll fix some other stuff that kids want to do all the time. Like this. And I get why they do this, but people want to say, well, oh yeah, I need to combine like terms. I got 7 X's and I got 11 X's. That's 18X. I get why you do that, but here's why that's wrong. Because what you would be doing is you're saying, okay, well, that's going to be plus 11X. That's how you would get 18X. What did we just say the number one rule is? So what do I need to do if I do that? I would have to do this. No exceptions. Whatever you do to one side, you have. That doesn't get me anywhere. It is totally, well, no, here's the thing. Let's talk about this. If you follow that one rule, there's no such thing as wrong, technically. I can still follow that step and get it correct. Even though that's not what I should have done, if you do the same thing on both sides, the equation is still in balance. It's still a correct equation. You didn't get any closer to solving it, like you did an extra step for no reason. So it'll take you longer, but you would still, I mean, I'll show you that'll work. 18X plus 8. I didn't do this in any other class, but so there. I just did that, right? That would be that step. Technically, that's what I would be doing if I try to combine them. Do I still have variables on both sides though? I do, right? Didn't help me at all, did it? So what would I want to do instead? What do I need to think about instead of combining them? I need to get rid of them on one side. That's how you need to think about it. When you have variables on both sides, you need to think about getting rid of them on one side. Not combining them when they're on opposite sides, getting rid of them on one side. So if you do that, now, again, this is killing a lot of you. Need zero noise. Even if you're talking about the problem, zero noise right now. So if I think about getting rid of them, now I don't have variables on one side. I only have them in this case on the right side. Those of you that did it correctly in the first place, you would still be at this same equation. So I get to the same place. It took me an extra step because I could have just subtracted 7x in the very first step. I could have gotten rid of those in the first step. But the key is if you follow that one rule, you can't mess up unless you do the math wrong. The equation is always in balance if you do the same thing to both sides. If you solve it out, you get 2.5. I'm not going to finish. You'd add 2, divide by 4, divide by 4. I am going to show you the other mistake it fixes that I see a lot. Let's say we have this. Something like that. Here's the other mistake I see. Kind of similar. You know you need to combine like terms. And you say, well, I know I need to combine that 5 and that -2. But you do it like this. I need to add 2 to get rid of it there. Because I need to do opposite math. So I get where you think this. So if I add 2 there, I need to add 2 there. But what rule did I just break? That's not the rule that I broke. I tried to combine them, I just did it wrong. What did we just say the number one rule is? Yeah, so what did I just do? I added 4 to the left, nothing on the right. So again, it fixes not all the mistakes that I see, but it fixes a lot of the big ones. If you follow that one rule, if you just make sure you got that rule ingrained in your head, you can't make 2 or 3 of the biggest mistakes that I see over and over and over again. What you would have done here, and again, I can still get to the right spot. That'll be a 0, 10x. That would be 7, but I would have to add 4. Well, I shouldn't do it there. I would have to add 4 to this side because I added 4 to the left, +2 and +2. So I'd have to add 4 to the right. You'd still get to the right answer if you did it that way. But the correct step when the numbers you're combining are on the same side, you just do the math on that side. We just say 5 subtract 2. So it'd be 10x plus 3. And then it would equal 12. We wouldn't have that. But like I said, if you added the 2 and the 2 on the left, then you followed the rule and added 4 on the right, you'd also get the same answer. Just make sure you follow that one rule. And eventually, if you do the math correctly, when you add and subtract and divide and all that stuff, you'll get to the right answer. You'll figure it out. We need to finish up line segment proofs, but really quickly. I'm not going to talk a lot about it. I talked more about it yesterday. If you want to watch yesterday's video, if you weren't here, you can. The number one deadline is this Wednesday. You have a deadline Wednesday for this angles incongruence, which is the one everybody should be getting on 100. That was not a difficult quiz. Some of you didn't even pass it though, so you owe me tutoring. I said for the tutoring, you could replace it with those 2 really easy IXLs. I don't remember the names of them. They're in your focus though. I want to say one was like 9AN and one was like YQW or something like that. I don't like look them up in your message, but I think something like those maybe were the 2 super. They're really, really easy, like way too easy. And if that's all you do, you won't do very well in the quiz. So you should really do either the practice problems from the book, which I did a video on that. Like literally in the video, I did some of your quiz questions. I just changed the numbers. If you watch that video, that should be enough. But in order to take it, you have to do at least this. And to replace that, you could skip that and you could just go straight to the book assignment. But you have to submit. If you do any of those online book assignments that I put in McGraw-Hill, you have to submit them. You don't have to do every problem. I'm not going to check every problem, but I need to see that you did them and submitted them so I can see at least that you got a few of them right. So make sure, no retakes Thursday. I'm tutoring at lunch and after school. Unless, oh no, I'm gonna tutor on everything that's left. So yeah, no retakes Thursday. So you got today, tomorrow, and Friday to do your retakes. And then the last one, the last red one, the 3D figures, that's next Wednesday. So you just have to take the blue one and the black one by the end of this week. But nothing on Thursday. I'm tutoring Thursday at lunch and after school on everything that'll be left. All right. So turn to page 164. We already did that proof. We're gonna wrap this one up. Yeah, I'm gonna redo it. I don't know how much we did in this class, so I'll just redo it. And we're going to go through really quick. I just want you to have a bunch of proofs that are completed so that you can kind of go back and look. It's almost easier to see the reason and it fully worked out and to figure out why that's the correct reason than it is to try to figure it out the first time on your own. But this is one of the rare exceptions for that. All right, what's the first statement we already said, or almost always we said? Yeah, like just make sure though, this is truly the given information. Like look up in the problem where it gives you something and make sure that is the given information. But normally we're going to start with given information. What's the second step? Yeah, no, virtually nothing changed. I mean, I took away like the little segment line symbol thing and I changed the symbol from congruent to equals, but all the segments are still the same segments. That's definition of congruence we said from yesterday. I'm going to abbreviate, so hopefully you have some notes from yesterday. If you weren't here yesterday, you can go back and watch the video if you need to. I said you should be able to do these here, so we'll do those first. What is 3? What do you think 3 is? So again, look, some of you give up before you even try. If you look at the figure and you trace what it's telling you is happening in 3, they're saying segment CE, which is one of the little ones, plus segment ED, which is another one, the other little one, equals segment CD. And that should be pretty clearly little plus little equals big. It also visually will look just like this normally. Not always, but normally. If I just kind of got rid of that E that's in between on both of the two segments, I'm left with the two endpoints. C and D are the endpoints of the big segment. And normally that's the way they will write it so that it looks like that. So that's another pretty good hint that that is little plus little is big, which we call segment addition. So we're skipping to the circled ones. What is 5? Yeah, it's the same thing, right? If you look, this is one of the little segments, that's one of the other little, and that's the big. Or again, if I get rid of that E that's in both segments, I'm left with the F and the G as the endpoints of the big segment. Segment addition again. And when you're doing a proof on segments, especially if they don't mention anywhere anything about a midpoint, you're going to have segment addition. There's not that many different things you can use for line segments. Segment addition is like the main one. So just know you might have it more than once. There's no rule saying you can only use something once. You'll use a lot of them more than once. Substitution, especially. What is 7? Not given. That's what we're proving. So I haven't really talked about that. Don't mistake this for given. That is not given. That's not true. That's what we're trying to prove is true. So that's different than given. Given is only this stuff up above where it's on the same line with the word given. And what we're trying to prove will always be the last statement. So what's the reason though that we'd write? How did we go from 6 to 7? That should be an easy one. No, you would see the subtraction. They would show that we subtracted on both sides, but you're not showing any math. Did anything really change? What's the only thing that changed? So what do we say that is? Doesn't matter if it changes from equal to congruent or congruent to equals. What's that? Definition of congruence. Yeah, these aren't changing and all that's changing is the symbol. That's still definition of congruence. Going from an equal sign to congruent sign or a congruent sign to an equal sign. Definition of congruence. All right, so now we've done most of that proof. What's the one thing we haven't used? Big one. Have not used yet. That I said we use a lot. Substitution. Here's another hint on substitution. I don't think I did this yesterday with this class. If you have a whole bunch of equal signs, you're going to be substituting. Like, that's what substitution is. You're taking two things that are equal and replacing them for each other somewhere else in the proof. And we got a whole bunch of things that are equal. Now, if you're thinking that, you just got to figure out where it might work. So I know these two things are equal. Well, let's see where else maybe I use something. Oh, look at that. Here's CE, right? And I went from CE to FE right there. Well, they're equal, right? That's substitution. I just replaced CE with FE because they're the same thing. They're this CE is the same as FE, same thing as equal, whatever you want to say, whatever makes more sense. Just to make sure, I want to make sure I'm doing that with the other stuff, though. I don't want to just write substitution yet. Well, sure enough, right there, I know that ED and EG are the same thing. I can switch them out for each other. Well, ED switched out for EG right there. And then this side is the same, so I didn't substitute there, but I don't need to substitute them. So that is substitution. So now let's look again. And again, you still can be thinking, okay, I might use substitution again, because that happens a lot, especially with a lot of equal signs. I'm trying to get down to these two things here. So let's see, I know CD, there's CD, because I'm kind of trying to find something that's in this, right? So there's FG, so there's the two things that are in line 6. Well, I know that CD is equal to all of this. Well, I see all of that stuff right below. So if CD is equal to all of this, or all of this is equal to CD, I could replace all of that stuff, right, which is right here again. I could replace all of that stuff with that. That's how they got to line 6. They replaced this stuff right here in the box, which is the same as this, with CD because that's what it's equal to. So they replaced it with CD. Again, if they're replacing something, then we are using substitution again. So substitution can be tricky to see, but I'll tell you right now, if you haven't used it in a proof, the odds are it's in there. You just got to figure out where, and if you can't figure out where, but you also don't know what else it could be, I'd probably just pick substitution. Even if you pick it for everything that's left over, pretty good chance it's at least one, if not two of those things that are left over. I think you only have to pick 2 blank lines on UFC. I believe that's what they said. All right, so we got to do one with a midpoint. So turn to 166. But again, it's still about line segments, even though we have a midpoint added in. So we could still be thinking segment or little plus little is big. Anytime you have line segments, little plus little is big, or segment addition. And then if they tell you midpoint, what is the one thing that midpoint tells us? Because there's really just one thing. But what's it tell us? What's that mean? Math, it is in the middle, but that's the midpoint and that's the midpoint. What is that telling us is true? Well, that's always true, even if it's not midpoint. But yes, we will want to think about that later as well. But what's the one thing that midpoint tells us? Here, just like two boys that I had in my 3rd period class that just sit there and play around all the time. That's what it tells us. Well, these are congruent. If I know K is the midpoint, let's do it in different. K is the midpoint, then that means, and I'm gonna write it out because I guarantee you will write it using it. KJ is congruent to KG. Like that's the only thing the midpoint tells you. So you're gonna use that if they're telling you you have a midpoint. It doesn't tell you anything else. Little plus little equals big is always true. So it's not telling us that. That would be segment addition. That has nothing to do with midpoint. So again, if H is the midpoint, they're telling me GH is congruent to HI. And they can flip the order of the letters, so just make sure you understand that. Because we don't know that these are congruent. That's what we're trying to prove, actually, I think. Yeah, we're trying to prove that those are congruent, but we don't know that yet. So I can't put only one mark. It looks like they might be, and ultimately that is what we're trying to prove. But for right now, I don't know that the red ones are congruent to the blue one. All right, so if you want, well, what's the first reason? Just take care of these ones. Yeah, it's given, right? Make sure you don't always assume, because it is possible that the given isn't the first reason. But, you know, be thinking about it. Look, you could also take care of this one also. Find that one in the proof. Where's that one in the proof? What line is that? Nevaeh, what line is that on? Look, GJ is congruent to GI. Where's that? What line? It's in there. Look in the proof. Don't look up there. It's on the left-hand side, the same exact thing. Not moving on it. Fine. You're looking for that in the blue circle. Look. Look. I'm gonna come over and beat you with this yardstick. Look. Is it in line 1? No, because that's about midpoints. Is it in line 2? Is it in line 3? Do you see GJ and GI in line 3? Is it in line 4? Yes. Oh my God. Given. This is right there. It'll always be in there. They're not going to give you something and not use it. So make sure you find it somewhere in the proof. All right, so now I told you that I'm going to be looking for these because that's the only reason they would tell me something is a midpoint. Well, and again, the letters in order could be switched around. Here's KJ, there's KJ. Here's GK, here's GK. Again, the letters can be switched around. There's that one right there. Well, just to make sure, GH, GH, HI, HI. So there's 2 reasons you can use for that. I don't think they'll ever put both of these in there because they really are the same thing. There's a slight, tiny difference. So you would either look for one of these. Midpoint theorem. Write that. I don't even know what the book uses. I'm just telling you there's 2 names. Midpoint theorem again means that if you have a midpoint, the 2 smaller segments are congruent. Or the other one, or definition of midpoint can also be the reason. No, you get a drop down, remember? You'll have a drop down. So you just need to be able to think, okay, yeah, that makes sense. That I'm talking about a midpoint. They're telling me those 2 segments are equal. So I want to choose the drop down that's about. I don't think they'll ever put both of these and make you choose between those 2 because there is a tiny, tiny difference between them. If they do that, then just take a guess. You use a midpoint theorem when it's got a congruent symbol. You use the definition of midpoint when it just says equals. So like if they didn't give us statement 2 and they just started with statement 3, we would use definition of midpoint. I don't think that even existed when we didn't learn those two different ones. I think we just wrote midpoint. We carved it in some. I don't know how I'm gonna test you on this yet. This will probably be, I mean, it will definitely be next week. So I don't know how many. I don't know. I'll give you, it'll be like if I give you a paper version, I'll give you options to choose from. Like it'll be multiple choice and you'll have all these different reasons and you'll choose multiple. I don't know that it'll be online. Now the district will give you one online eventually. Then yes, that will have the options. How do we get from 2 to 3? What's the reason there? So line 3 would be what? That's one you need to practice and have down. Study that one. It's an easy one. How do I go from 2 to 3? What changes going from 2 to 3? Think about that way. That's it, right? So definition of congruence. Almost nothing changes. If you're looking at it going, well, nothing really changed except for that symbol, that is definition of congruence. Again, you don't have to memorize it, but you need to understand it enough to recognize it in your dropdown. So definition of congruence. That's a pretty common one in the book. I don't know if it's going to be common on the EOC or not, but the book uses it a lot. Yeah, they'll use it in angles too. You'll see when we do angles, it's in there also, I think. Actually, if it wasn't. We didn't get through many angles problems. We already wrote given for number 4. What's number 5 then? Same thing, right? Almost nothing changed except for the symbol. So if you're thinking, well, nothing really changed, probably definition of congruence. That word is congruence, whether you believe that or not. 6. Oh, there it is. Okay. So what do we actually tell you what? Go ahead and take care of what's the last one? How do I go from 10 to 11? Definition of congruence, right? So let's just take care of that. All I did is change the symbol to go from 10 to 11. All right. We have one about segments still, right? So what are the 2 things we haven't used that are the big ones for segments? Subtraction could be used in anything. And plus, I'm not really seeing, like they would typically show me subtraction and they're not showing me any subtraction. Somebody said one of them. Substitution we haven't used. Is that what you were saying? Segment addition. That's what you need to be thinking at this point, because we still got a lot left. You won't always use segment addition if they're telling you something about a midpoint. But if you got that many blanks left, there's a pretty good chance you're going to use segment addition. So look at the picture, see if anywhere they're using something about little plus little is big. Or if you remember, visually, that's what it looks like when they're writing it with the letters, naming the segments. So I'm pretty sure you can verify by looking at the picture. I'm pretty sure line 6 is segment addition. That would be little plus little is big if you look at the picture. Again, you could still use that again, but here's another little tip. If they're putting 2 things on one line, like you see how they have that semicolon in the middle and they're putting 2 things on one line, a lot of times that means you won't use it again because they took care of both of them in one line. So that kind of leads me to think maybe I don't use that again. Doesn't mean you won't for sure. Like up here, we took care of midpoints twice really on line 2. So that's why we didn't use it again, even though technically they gave us 2 midpoints in the given information. What do we still not use? Dorian. Still haven't used substitution, right? That's going to be somewhere in here. We got all these equal signs all over the place. I would say we're probably going to use it more than once. If we got that many equal signs and we haven't used it at all. Like, yeah. Let me get rid of some of that. All right, so let's see.
here's an easy place to start. Is there somewhere where I can, is GJ equal to something that I could substitute in right there? Well, right below. GJ is equal to all of this. So let me see if that makes sense. Did they substitute all of that in for GJ? Well, yeah, the very next line just goes from this. Again, it's hard to explain it sometimes. But I just move that down on the left side and replace that. So again, same thing. Is there somewhere where GI is equal to something that I could replace that GI with? Well, again, very next line. GI is equal to all of that. So they're just going to kind of replace GI there with all of that. So this equation became this equation because I just substituted in that stuff on line 6. That's how kind of 5, 6, and 7 work together. And a lot of times they will work together all right next to each other. So that's kind of a little hint. Not always. Sometimes you got to look around a little bit more. All right. So now, oh, so substitution. Substitution there. Again, doesn't mean we're done with substitution. We can still use that another time, 2 more times. So how do I go? What change is going from 7 to 8? It's more than just the symbol. There is something that changes besides, actually the symbol doesn't even change. What's the only thing that changes going from 7 to 8? 2 things. Well, the number does change, but something else. That's a technicality. That changes to that, right? The GK is still the same. The GH is still the same. So again, I'm replacing, again, if you ever think I just replaced this with that, that is substitution. So go up and see if these 2 things are equal somewhere. Is KJ equal to GK? KJ right there is equal. So if you see, well, I just replaced that thing with that thing. Pretty good chance. I mean, that's literally what substitution means, replace something. So if you just see all I did is replace something, pretty good chance that's substitution. Go up and see if somewhere up above those things were equal to each other. And sure enough, they were. So you may want to write that note. Like if you're thinking to yourself, well, I'm just replacing that with something else, that is substitution. From there, it's a little trickier. All we did here is algebra. GK plus GK is 2GK. That's just like X plus X is 2X. So that would be just anytime you think to yourself, well, they just did the math. That's all they're doing is the math. That's simplified. Is what your reason would be, at least according to this book. Hopefully this book follows the EOC. They don't really show this part to you, which I'm kind of surprised because they showed it in other problems. They did math to get to that also, but they didn't show you what math. Does anybody know what we did? Not subtraction, because if I can't really subtract and get rid of a 2. Not that 2. Division. So I would say that's the division property of, even though they don't show me the division, I would say that's the division property of equality. It's possible that they might call it simplify in the book. Because they did, again, doing the math, it's called simplify. Showing the math would be more of the division property of equality. I forgot to write property in there, but so division property of equality. So there's a pretty good proof worked all the way out. It's got a lot of stuff in it. It's got midpoint. It's got segment. I was like, where's the segment addition? Segment addition. It's got substitution. So there's a good one worked out for you. So on the page, yeah, we'll save that part. On the page, it is the practice problems. Do number 1, number 2, and then I think the second page, number 10, where they've already got proof set up. Number 1, number 2, and number 10. I think it's page 169. You'll see if you go to it. Look at page 169. Oh, I'm wrong. 167 maybe. Yeah, 167. So you're doing number one. Now, and I'll probably work these out like I do with a lot of the practice sets. I'll work them out online so you can fill in the gaps if you're struggling, because this can definitely be a little tricky. All right, so we got to fly through angles. So go to the next lesson. Angle relationships, page 171. The good news is, even though we're flying through it in 6 minutes, we've done almost all of these already. We did them relative to line segments, but they're kind of the same thing. Or we did them when we did angles before. We're just giving them an official name now. So protractor postulate, not really a big deal. It just means we can measure angles with numbers and in degrees. I'm not going to really worry about that. Angle addition postulate. Any guesses at what that means? We just did segment addition. What was that? So what did we call that? Or way back in the day, we started by calling that what? Yeah, that's little plus little is big. And it could be multiple littles, not just two. So that's that. Again, same concept as segment addition, only it's with angles. A supplement theorem is not new either. If I have a line, how many degrees in a line? 180 degrees, right? We said that before, nothing new. I split it into two angles. What's got to be true about angle one plus angle two? Eli, you're waking up. What's got to be true about angle one and angle two? So that's now just officially, we called it a linear pair before, which it is still a linear pair. And sometimes you will see linear pair as a reason. So don't think you always use supplement theorem. Sometimes you will see linear pair, but it means the same thing. It's just, I doubt they would ever put both of them in the drop down. So linear pair, definition of linear pair, or supplement theorem could all be reasons that you use for that situation. Complement, again, we've kind of done that before. Only if I have a 90-degree angle, because that's what complementary means. And I split that into two angles, then the two angles would add up to be 90 degrees. I have a right angle and I split it in two. So not really new stuff there. This is a little new here, and we got to do it fast. I'm really just doing a math problem. Like that's all they're doing. They're just solving for one of the angles. That can be done as a proof. You can explain why you can do each step. We don't ever explain them when we solve out problems, but technically you have to be able to explain why you do the steps in a problem. Down here, we can subtract that from both sides. What would that be? That should be a simple one. I subtract a number from both sides. We did that before. What was it? Give me at least one word. What am I doing to both sides? When I'm not substituting, I'm doing what? What I just underlined. I'm subtracting, right? So that is the subtraction property of equality. Anytime they are showing you math being done on both sides, that's the property of equality thing. Because I have to keep it, that's literally whatever I do to one side, I got to do the other, property of equality. I'm just doing the math on the last step, so that would be simplify. What is the first step? Say it again. It's not given exactly. They are kind of hinting at it. I have that big angle. What's true about those three angles then? Oh, come on. I gotta tell you. That's little plus little is big. Only there's three littles. So this is little plus little plus little equals big. So that is angle addition. The next one is substitution. I gotta just kind of wrap this up so it's on video. Substitution. I just replace the measure of the angle with the number, which just comes from up here. So I'm just substituting in what's equal. And then you're just doing the math. So simplify there. And then really super fast. Do not pack up because there's one you got to know. That's why I'm rushing to get to it. So look at page 173. You have to know these three. These are actually kind of big examples. So reflexive, that means that just something is equal to itself. I'll show you an example of that in a minute, why it's important. Symmetric means if one angle is equal to another one, then you could flip that around and say angle 2 then is equal to angle 1. Here's the big one you got to know. Transitive is like substitution. So write in your notes. This will be used instead of substitution a lot. So if you don't see substitution, we're like, man, all they're doing is substituting. It's probably that property. That's a big one. They will oftentimes not put substitution in, but they will call it the transitive property, even though it really is just substitution. I don't know why they call it its own separate thing instead of substitution, but they do have a separate property for it. But that's a big one. The reflexive property is a big one too, but we'll get to that when we get to triangles, so I'm not going to worry about it. Yes.